So Joshua Smith asked, can you make a series on the tabs in EV3 and what you do with each block? So I've already made one on the action tab and one on the flow control tab, and so now I'm going to make one on the sensor tab, the third one, or the yellow tab. So a lot of these sensors are pretty similar in what they do, but I'm just going to run through them kind of bam, 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 bam. So the first one is the brick buttons. This is a data wire output that outputs what brick button is pushed in. And the other choice is compare. So you can say, and this is the IDs for each brick button. Down is 5, 4 is up, 3 is right, 2 is center, 1 is left, and 0 is nothing. And you can choose which ones, all of them if you want, and then you can select what state, and then it will give you a logic data wire if it is true or false, and also the same thing as if you just measured the brick buttons comes out right here. So that gives you the button ID of what's pressed, even if it doesn't make it true. Well, that's that block. The next block is the color sensor. So the modes for this one, oh, and the brick buttons doesn't have a port because there's only one set of brick buttons on the thing. The color sensor, it has a port. It's up in the upper right corner, sorry, not left, and you can choose 1, 2, 3, 4, because those are the sensor ports, or wired, which allows you to plug in 1, 2, 3, or 4 for the port. So what you can do with the color sensor is you can either say, give me the color ID, that's measure color. You can do measure reflected light intensity. I'm going to set it to a normal port so it looks normal. Set it measure reflected light intensity, where this data wire gives you the reflected light intensity, which is how much of the red light it's shining is bouncing back to it. That's white is close to 100, black is close to 0. Then there's also measure ambient light. This is how much light is in the environment, so it's just listening. It's not putting anything out there. Then there is compare color, which adds the compare statement. It gives you the same choices as the one with the brick buttons. Compare reflected light intensity and ambient light intensity. They're the same thing as measure. And then there's calibrate, reflected light intensity minimum. And this lets you say this is the minimum it'll see. And there's maximum and reset, which resets the calibration. The calibrate function is interesting, but it's not the most accurate way to calibrate. I'll maybe do a video on that. If you want a video on that, put it in the comments below. The next sensor along is the gyro sensor. It also has a port. You can choose 1, 2, 3, or 4, or wired. The modes are measure angle, where the data wire gives you angle. Measure rate. So measure angle is what angle the gyro sensor is pointing in along the axis of rotation that the arrows on the gyro are in. So if you have a robot that turns and your gyro doesn't change, that's because your gyro is either not plugged in, on the wrong port, or it's rotated sideways on your robot. So it's actually measuring whether your robot tilts up or not. Then there's rate, which measures how fast the gyro sensor is spinning on its axis of rotation. And then there's measure angle and rate, which has a data wire for both. Then there's compare, which adds the compare values for both angle and rate. And there's reset, which resets it to 0. The next block along the line is the infrared sensor. I don't do much with the infrared sensor because it's not allowed in FLL, but it's pretty similar to most of the other ones. Ports 1, 2, 3, 4 and wired. Measure proximity. That's how close something is. Gives you a data wire of how close it is. Measure beacon. That is what channel the controller is. And the heading, the proximity, and whether it's detected or not. And there's also measure remote, which what that does is, so this one, measure beacon, lets you set up beacons, lets you tell you what angle it's at and how far away it is, whereas measure remote asks for what channel it is and what button on the remote has been pressed. Then there's also compare with proximity, beacon heading, beacon proximity, and remote, adding the compare values of all the other ones. So there's a lot of things in common. There's the motor rotation, where this time the port, instead of being 1, 2, 3, 4 or wired, is A, B, C, D or wired, because this is actually built into the motor, and so it measures the motor rotation for the motor plugged into the port you specify. So that lets you choose measure degrees, where the data wire has degrees, like how many degrees the wheel has spun, or motor, not just wheel. Rotations, how many times the robot has rotated. This is a float, so that means there can be halves of rotations and fourths of rotations. And you can measure the current power the robot is traveling at. Then there's compare, which same thing as before, but it adds the compare stuff. And there's reset, which resets all the degrees and rotations it's read back to 0. The next block is the temperature sensor. Again, I haven't done much with this one because it's not legal in FLL, but you can choose your port. You can choose measure Celsius, measure Fahrenheit, compare Celsius, compare Fahrenheit. I don't think I have to touch more on that. It's pretty self-explanatory. The next one's a little bit weird. It's the timer. So you can have 8 timers going at once, timer IDs 1 through 8, and you can read how much time has gone past since you started. That's when you measure time. You can compare time, which adds the compare stuff, and you can reset a timer ID back to 0. So you can do things, if you were to say measure time, at the beginning of your program, it resets all of them to 0, but then you could say read this one until, the elapsed time equals 5 or whatever, and then reset it. That would be kind of pointless, but make sure it never goes past 5 for whatever you were doing. The next one along is the touch sensor. This is basically a giant button. So you have the port choices 1, 2, 3, 4 wired, and you can measure the state. So this right here is a logic that says true if it's pressed, false if it's not. And then there's compare state, which adds the compare stuff. Next one along is the ultrasonic sensor. This one's pretty cool. You can choose between ports 1 through wired, and you can measure the distance centimeters, measure the distance in inches, measure the distance in centimeters, self-explanatory. How far away is something within centimeters? Unless it's closer than 1 or further away than 255. If it's closer than 1 or further away than 255, this will read 255. Otherwise, it'll read how far away it is. Same thing with measure inches. Measure presence will give you a true if there is an ultrasound coming at your robot. So that means if there's another robot's ultrasonic sensor that's pointed at yours and is trying to figure out how far away you are. This would be cool if you were building something like a SumoBot, where normally what happens is you spin till your ultrasonic sensor sees the other robot and then you charge at it. With this, you could know, has my robot been found by the other robot, because you would have received an ultrasound. And so that would allow you to do things like, okay, that robot's about to charge at me. If I back out of the way, what's going to happen? You can do cool stuff like that. And then there's measure advanced centimeters and measure advanced inches. The only difference between advanced and normal is it allows you to choose measuring mode in ping, where it asks it right then, or continuous, where it will take 3 or 4 or 5 and average them. So minor differences there. Then there's the compare, distance centimeters, distance inches, presence listen, and actually compare presence listen and measure distance listen changes nothing at all, but the compare distance centimeters adds the compare stuff, and the compare distance inches adds the compare stuff again. Then there's the energy meter. Again, I don't do much with this because you can't use it in FLL. There's ports 1 through 4. You can choose measure voltage, current, wattage, out voltage, out current, out wattage, and joules. And you can do the same thing with compare, and all those are just different ways of measuring how much electricity is going through. The next block is the sound sensor block. Well, sound sensor block lets you measure the decibels and the decibels amplified. Compare the decibels and the decibels amplified, and calibrate the decibels at minimum, maximum, and reset it. It also has the ports 1, 2, 3, 4 unwired. That's pretty much all about the sound block.